In previous class, we had studied about the physical methods of concentration of ore, that was gravity separation, magnetic separation, flotation, and one chemical method, that was leaching of ores. Okay, by that we have concentrated. We have initially removed. Concentration means what? Concentration means initially removal of gang particles present in the ore. Today we will see working on ore or working of ore. So once you got concentrated ore, that means initially all the gang particles, maximum gang particles are removed. Then it is sent for the next stage for further processing. So working of ore involves mainly two stages. It involves mainly two stages. First stage, in first stage, first the ore is converted into its oxide form. Either the process may be calcination or maybe roasting. So in first stage, the ores are converted into metal oxide either by calcination or that means the ore are converted into metal oxide either by calcination or by roasting. By these two methods, ore are converted into its oxide at in stage. In the second stage, this is step 1 and this one is step 2 of working of ore. In step 2, the conversion of oxide, metal oxides form. This conversion of oxide into metal by smelting. We will see this process. Uh, so the conversion of oxides, there are two stages involved. First stage, the ores you found after the concentration of ores. Initially, I repeating, initially the gang particles present in the ore is removed, and thereafter, in next stage, the ores are converted into metal oxide either by calcination or by rusting. And in second stage, conversion of oxide into metals, metallic oxide formed in this first stage. In this first stage, the metallic oxide are formed. These oxides are converted into metal by the process of smelting. So we will see here. We will see what is calcination and roasting. This one is roasting. Calcination. Calcination. What is this calcination? Actually, calcination is the process of heating ore in the absence of air. This is the process of heating ore in the absence of air. And what happens? Why we heat the ores at higher temperature in the absence of air? By heating the ores at higher temperature in the absence of air, the molecules are degraded or broken into smaller molecules. So actually, the word calcination is derived from the word calcite. When calcite, the ore of calcium, when heated, calcium carbonate when heated at higher temperature, it decomposes into calcium oxide and carbon dioxide. For example, we can take calcium carbonate when heated at 1200 degrees Celsius temperature. It decomposes into calcium oxide and carbon dioxide. Again, calcium oxide is formed. Then, calcination is the process of heating this ore in the absence of air at higher temperature. At higher temperature, it decomposes into its simpler molecules. So, also, when ore contains magnesium carbonate and calcium carbonate, when these are heated, then magnesium oxide plus calcium oxide are formed. 2CO2. So, in the process of calcination, when the molecules are broken down, if any moisture content present in the process of concentration, so that moisture contents also vaporize. Also, volatile components present in the ore also vaporize at that higher temperature and pores becomes porous. That means pores become in this process of calcination, pores become porous. Little bit spongy. Sponge is also porous. So, that type of structure gains by pores after heating at higher temperature. This helps in further processing of the pores. So, next one is this one calcination. Next one is roasting. Roasting is the process of heating pores in the presence of excess of air. So, roasting is just opposite of calcination. In calcination, you have seen the ores are heated or ores were heated in the presence of, sorry, in the absence of air. Where in the roasting process, ores are heated in the presence of or excess of air. What happened? Then with the excess of air, all the moisture plus nutrient, volatile combustible matter are removed during the roasting process. And also, these ores, due to excess of air, ores are converted into its oxide. So, by the process of roasting, ores are converted into its oxide, and in this process, ores also becomes porous. In both the process roasting and calcination, ores becomes porous so that it can easily react in the next process. So working become very easy. Next, next processing is next working on for is smelting. What is smelting? What do you understand by this smelting process? So, smelting is the process of extracting a metal by fusion of the oxide ore with carbon. Smelting process we apply, and in this process, the fusion of metal or fusion of the oxide ore with carbon takes place. In the process of fusion of oxide ore with carbon. Since all the impurities are not removed in the previous process, some little bit of impurities or gangue particles always remains with this ores. So, to remove that gangue particle, finally, some additive substance are also added. That additive substance are called flux. So, flux are also added to this process to remove the gangue particle. So any gangue particles present in that react with the flux and forms slag, and these fluids actually by the fusion process in a smelting, the ores are separated, the metal is separated from the ore, and the flux reacts with gangue particle and forms infusible substance, slag, and now metal and slag do not mix with each other, do not fuse with each other. There is a separate layer of slag and metal, and this slag is lighter than metal, which floats over the surface of molten metal, which is removed first, thereafter metal is removed. So we can understand much better. Suppose that we can take an example. Suppose that we are processing and silica is SiO2 or sand particle, we say that is what? Silica, silicon oxide. This is present in as gangue particle in the ore. What happens? This one is gangue. Then you add an additive substance called flux. So as flux, you add calcium oxide. So depending upon the nature of the gangue, we use the flux. Here, SiO2 is acidic in nature. It is acidic in nature. So basic flux are used. Basic in nature. Okay. So to neutralize this acidic, SiO2 is acidic in nature, we add calcium oxide, which is basic in nature. This forms calcium silicate, which is this one is plus and this one is minus. But when ionic particles are basic in nature, we take acidic flux. So it will depend whether we are taking what is the nature of our flux we are adding. What is the of gang particle present in that core. So this smelting process is generally carried out in blast furnace in the manufacturing of or extraction of iron from its ore. So actually we will study the details of this whole process, what happens in the metallurgy of iron, what happens in the metallurgy of aluminium. So we will use this when we say there is by roasting or by calcination process, the ore has passed, then you must know what is calcination, what is roasting, and what is smelting. There, one word is used by smelting. This happens. You must understand what it is. So, last step is refining. After you got the metal, that metal is not in pure form, so you refine it. Refining may be done by several uh, types. It may be electro refining, cooling. Third one is liquefaction, and fourth one bloom refining. There are several processes of refining depending upon the nature of the metal. We choose the process by which it may be refined. So first we will discuss about this electro refining. What is this electro refining? So actually it is the process of electrolysis in which you take impure metal as an anode and pure metal as cathode and use metallic salt, same metallic salt, and when electricity is given, the impure metal block at anode melts and goes into solution, and from that solution it goes to cathode. It is deposited to cathode. The whole process continues till the impure metal disappears at anode. So this is the process of electro refining. By using electricity, we refine the impure metal into pure one. Next one is polying. Second one is polying. Molten, there is molten metal, and in this molten metal, green loss in falling, green logs are used. Actually, calling is used for reducing oxides from the metal. Here, impure metal is melted on a shallow earth. This is shallow earth. Okay, here you are heating that. So, this metal is heated in a shallow earth of a reverberatory furnace, and molten metal is stirred. This molten metal is stirred with green logs. During stirring the green logs, the gases of by green wood, any metal oxide present in is reduced to metallic state. That means here metal present metallic oxide, if any present in this molten metal mass, this metallic oxide reduces to metal. Actually, oxygen present with this metallic oxide reacts with and forms and escape as different gases. Suppose that if any impurity, sulfur is present or any other is present, it reacts with oxides and forms SO2, and it is removed as SO2 gas. And either that means in this falling process, the impurities either get removed as gas or it comes over molten metal. Sometimes it happens it is just forms its lumps and it spreads over molten metal and it is removed. So by falling, refining of metal is done. In liquefaction process, third one is liquefaction. Third one is liquefaction. What is this liquefaction? In liquefaction method, the metals which have low melting point are purified. Actually, a sloping earth is taken. This is hitting from here. This is a stream, and this sloping earth, the crushed metal are just put on this sloping earth, and it is heated. The metal having lower melting point with respect to the gangue particles present in that. So metal started to melt first, and this comes down. This is collected here, and this is a stream to filter solid particles. Okay, so I am repeating, in this method, this impure metal is heated on a sloping hearth of reverberatory furnace. Here, carbon monoxide is used to make environment inert, and the metal is in pure form. The metal is in pure form. When we heat, this started to melt. That means pure metal melts and flows down, leaving non-fusible impurities present in that, and this pure metal is collected in a receivers at the bottom of this floating. A screen is put here to filter any solid particles. This was liquefaction process. Purification of lead purification of lead is done through this process. Next one is June refining. What is June refining? Consider a long bar of metal which is technique that actually consider this one is, let me first draw the figure, thereafter we will discuss. Actually this is bar of iron, not iron metal, any metal which is to be purified, and this is heater around that bar. So actually this method is applied for preparing very highly pure or high quality of pure metal such as silicon, germanium, which is used as a semiconductor. Semiconductor type of material, if we want to prepare, we purify by June refining method. Actually, this method works on a principle that melting point of substance is lowered by presence of impurities. That means if impurities are present in metal, then the melting point of metal is lowered, and consequently when an impure molten metal begins to solidify, the pure substance crystallizes with impurities remain in the liquid. Suppose that this impure metal which contains impurities which has lower temperature, and when it will solidify, then the impurities will remain in this bar. So in this method, the impure metal is first cast into thin. This impure metal is first cast into a thin cylindrical bar, and heater is slowly. This heater is very slowly moved through the bar. What happens at heated zone? This is the heated zone. Heated zone, the metal here melts, and as you move this heater further, then the impurities will move with this heater and it will deposit here, which is cut at the last moment, and leaving behind pure metal. That means impurities present in the metal will just pass through or just move with this heater to this end. From this end to this end, if you are moving heater from this end to this end, so this is the impurity will also move with the heater to this end. So the metal becomes pure. If you repeat, we may prepare ultra fine metal. So this was June refining. This was June refining. These are the techniques used for metallurgical process. Next day, we will see the extraction of iron. Okay, today we will stop here. Okay, have a nice day to all of you. Thank you.
Hello. Hello. Hello.